So, I still want y'all to talk. Remember, the more you talk, the better this is, and it gives me a chance. Because remember, when I ask you a question, I really do want to be able to take a drink of water. So, as we start to roll, what chapter are we in? 3. We're in chapter 3, not chapter 2, but chapter 3. Okay, so we have learned that this chapter is all about the energy systems. So, we begin to see that it actually starts with drawing the line down the middle of things. Remind me what twitch fibers we are talking about over here. Type 1. Give me some characteristics.
Slow force production.
Very good. Slow force. What else?
Slow contraction speed.
Slow contraction.
You don't like the S word.
I know.
Yeah.
Delayed force.
I like that. Delayed. You just gotta wait for it. Okay? It's worth it. Wait for it. Wait for it. Okay, so we actually call these aerobic based or anaerobic? Aerobic. Okay, so let's jump over to this side because this is really what we've become really good at. We're really good at type 2 fibers. Which ones of these live closest to the line?
A.
Type A. Which ones are way over here?
X.
Type 2X. Which ones are the most explosive?
X.
Type 2X. Okay, so remember, everything like the strike of the match that kicks this entire fire going, slide the box open of matches, and so what is that called over here? Sliding filament theory. What starts first?
Calcium.
What triggers next? Trip and trope. Okay, then what happens next? Acetylcholine. Acetylcholine is a what? A neurotransmitter. Okay? Remember, that's that whole thing with the power stroke thing. It lets it go over and over. So after acetylcholine excites it, stimulates it, we actually see ATP going to ADP, rocking around and going again. Now, what we understand is that when you burn anything, you end up with a byproduct. Campfire, the next morning there's ashes. Okay? So what do we get, or what is the primary fuel for the phosphagen system? P-H-O-S-P-H-A-G-E-N. ATP. Okay, so whenever we burn ATP, what do we get? Creatine phosphate, CP. Now, remember this is what we talked about. The only athlete that would ever benefit from creatine supplementation would be which athlete?
Type 2X.
The type 2X athlete. So if you've got your athlete, your 800-meter runner, your 5K runner trying to say, I'm taking creatine, you're like, dude, you've got expensive urine. Remember us talking about that? Okay, so when we think about if this is the primary fuel, I end up getting creatine phosphate. Now, what's my duration of the phosphagen system?
0 to 6 seconds.
0 to 6 seconds. Hey, test. What page is the chart of all charts on? Page 54. When in doubt, look at the chart on page 54. Okay? The chart on page 54 reveals so many answers to the universe. Okay? So we see, what is this? Is this high intensity, low intensity? Give me some characteristics. High.
First 6 seconds.
First 6 seconds. So what do I have with power output here? 90 to 100% of maximum power output. So all of those things come into play. This is bam and done. Now, one of the things that Jake and I talked about after class is there is also another fabulous chart in this chapter, and it is on the bottom of page, where did we go with that, Jake? It's on the bottom of page 60. And it talks about work to rest ratios. So here's an example. Let's just say in the phosphagen system, I like to use kind of 1 to 10, 1 to 20 because it's easy math. So for example, if my ratio there is 1 to 10 or 1 to 20 even, okay? Let's say I'm having an athlete work for 3 seconds. How much rest do I need to give that athlete to reload that ATP bucket? 30 to 60 seconds. Because if I'm working for 3 seconds here, I've got to give them 30 seconds, upwards to 1 minute, to really rest, refill that ATP bucket so it can be ready to generate max force over again. Now, go back to the example. If I all of a sudden had someone vertical jump without a rest in between, what's going to eventually happen to that vertical jump? It's going to go down. And so all of a sudden, what's going to happen to my force production? It's going down. That's why you're not allowing the bucket to refill so that it can provide that explosiveness again. How many of you think that you've been asked to deliver maximum force and not given enough of a rest interval for your bucket to refill? Did your force production go up or go down, Kendall?
It decreased.
It decreased. This is why. This is why. Because we have coaches that are trying to design training programs that don't match up with the way the body is designed, because apparently the body will respond to whatever you ask it to. So think about this. If you're going at this maximum intensity and you're not allowing work to rest ratios, think about it. If that athlete is able to deliver 100%, you don't let them fill up with 100% saturation of ATP again. How can they deliver 100% ever again? You're only giving them 80 to 90% of their ATP. Well, that's what you better expect in return. So instead of giving them the full match, you're giving them a match that's about this big. You can still start a fire, but man, it ain't gonna be that full time to transfer to that other fuel system. So you got it when you got it? All right, so when we start to think about going back to, we're still reviewing, okay? Remember your ATP stores, you guys remember you've only got 80 to 100 grams. That's only 3 ounces of ATP. It's not very much. Remind me, what happens when you run out of ATP? You're dead. Okay, then we start talking about the glycolytic system as we transfer. Now, listen. Is the event that you're training for, is it determined by the, this is actually a test question, so I want to say it right. Wink, wink. Okay? Is the event based on intensity or duration? It's based on intensity. It's based on intensity. When we give these duration windows, you can't say you worked for 6 seconds, sorry, it's over, you've changed systems. The energy system is dependent on intensity, not time. The time windows that are given on that cool chart are basically reference windows. Everything is driven on intensity. Everything is driven on intensity. Everything is driven on intensity. Excellent. So as we start to decrease the intensity, yes or no?
Yes.
Yes. We have to move to a different fuel source. Okay? So now, instead of being in the phosphagen system, we are in the glycolytic system. Okay. What is the primary fuel for the glycolytic system or glycolysis. Those are interchangeable words. Glycogen. Okay, hey, where are the two places that glycogen is stored? Muscle and in the liver. What's the process called where I exchange glycogen between my muscle and my liver? Starts with a C. Cori cycle. Okay, so this is Cori cycle. Okay, you primarily use muscle glycogen over here. You use liver glycogen over here. Okay, remember, so when you're exchanging all of this, so basically by the time you get over here to aerobic, you actually have run out of muscle glycogen and you're tapping into the stores in your liver. So I got it when you got it.